Hi guys, welcome back to a new IMONST video. So in this video we'll be talking about last year's IMONST, which is the first of the hurdles that you need to cross over to get into the camps. So in this video we'll be talking about problems 1 to 5, junior only. Okay, so it'll be quite a quick one. I hope so. So for problem 1, the number n is the smallest positive integer with the sum of its digits equal to 2020. What is the first leftmost digit of n? This is quite an easy problem. So if we want the smallest positive integer, one of the things that we need to realize is that the lesser the number of digits, the better. So lesser digits is the best thing. And then, so how do we minimize the number of digits? Of course, we want to maximize the value of each digit, right? Maximize value of each digit, the biggest being 9, so like this one, right? So let's not do 2020 first, let's do a small number, let's say 25. So if we want the smallest positive integer, of course we want 9s to appear here, and then after having two 9s we're left with a 7, and then using these 3 digits we want to have a smallest positive integer. Of course, we want to put 7 in front. Also, you can see that 25, when divided by 9, leaves a remainder of 7. So as you can see, so using this, we can perform the same action on 2020. So since we want a lot of 9s, so we will have 18. Okay, so this is 2, and then this is again another 2. Then we have 4, so it would be 4, so the remainder is a 4, meaning that the smallest positive integer n would be something like 49999. Here we have 224 9s, right? So what is the leftmost digit of n? So we can see here it's 4. Very obvious answer. Hope you guys don't have much difficulty. Now let's move on to problem 2. It's also very easy. At a food stall, the price of 16 banana fritters is Rmk, and the price of k banana fritters is Rm1. So what is the price of one banana fritter in cent? Okay. So let's count in cent to ease our process. So the price of 16 banana fritters is say x cent. Okay. So okay, let price of one banana fritter be x cent. Okay, so 16x is Rmk, so Rm1 is equal to 100 cents, so we have 100k, and then we will also have 4 banana fritters, so kx is equals to 100, right? Something like this. So we see here we have 100 here, and then we have another 100 here. So we will have 16x equals to kx times k, which is k square x. So we can divide by x on both sides. We will have 16 equals to k square. K square minus 16 equals to 0. K plus 4, k minus 4 equals to 0. K would be equal to negative 4, but this is impossible because we don't have a negative amount of banana fritters, so the k can only be 4. Okay, so the price of 4 banana fritters is 100 cent, right? So the price of one banana fritter is just 100 divided by 4, obviously, would be 25 cent. Okay, so this is the answer to problem 2. Very quick, let's just go over it. Now for question 3, we are given a trapezium ABCD, so with AD parallel to BC, so we would draw something like this, AD, then parallel to BC. And then we also see that since it's parallel, it means that they don't intersect each other. We use both of these arrows to represent them. Then okay, I need to edit my picture for a while. Give me a moment. Okay, so, and then angle A and angle B are 90 degrees, so just draw 2 squares here. And then it is known that the area of the trapezium is 3 times the area of triangle ABD. So we can draw something like here. This is our triangle ABD, and then our whole trapezium ABCD will have an area of 3 if this is 1 unit, right? So find the area of triangle ABC over the area of triangle ABD. So let's draw an auxiliary line. Auxiliary lines are very important in helping us understand what's going on, can facilitate the process. Now, since I want to introduce you guys to a new notation, which is this one, the middle bracket. So normally we just use the middle bracket to denote the area. So if I say A, B, C, D, and then I put it in the middle bracket, it just means the area of this trapezium quadrilateral ABCD. Then over the middle bracket again, and then we have ABD. So this one is, since the trapezium's area is thrice, just 3 over 1, right? So doing a bit of subtraction, we find that the area of BDC is just 2, if this is 1 unit again. Now, observe that the heights of triangles BDC and triangles ABC are the same, okay? So heights of triangle BDC and triangle ABC are the same, because it's just because AD and BC, as previously mentioned, are parallel to each other. So you can move this point D to this point A, and then the area wouldn't make any difference, and then they also share a common base. So using these two, we know that their area is the same. So since the areas are the same, so if BDC is 2, then ABC is also has an area of 2 units. Now, so we want the area of ABC over the area of ABD. Since we know that the area of ABC is equal to that of area BDC, then we have ABD over here. So we have 2 over 1 is just 2. So the answer to problem 3 is just 2. Hope you guys understood my process. Now, for question 4 over here, this is a bit tricky, but we'll try and solve it as fast as possible. So each triangle symbol in the expression below can be substituted either with a plus or a minus. So we have triangle 1, triangle 2, triangle 3, triangle 4. How many possible values are there for the resulting arithmetic expression? So of course, if we put a minus, then it's smaller, and then if you put a plus, then it's bigger, right? So what would be the maximum of this arithmetic expression? So let's kind of find it out, and then we also need to find the minimum. So obviously the maximum is just by putting 4 plus signs, which is plus 1, plus 2, plus 3, plus 4. Now, which is 10, positive 10, and then the minimum will be negative 1, negative 2, negative 3, negative 4. It's just minus, I'm just saying negative for some reason, is negative 10. Now, how do we alter the values here? So observe that if we change a plus 1 to a negative 1, the value changes by a 2. Likewise, if I change the positive 2 to a negative 2, value changes by a 4. Then plus 3 to minus 3, we will have a minus 6, and then plus 4, and then becomes a minus 4, will become a negative 8. So we could do operations of minus 2, minus 4, minus 6, and minus 8. Observe that all of these are even numbers, and then both of these are also even numbers, which means theoretically that all the even numbers between 10 and negative 10, including both of them, we can produce these values, right? So all the values from like negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. All of these are possible. But if you want me to list them down slowly, I can try and do that. So let's do it one by one. So for 10, obviously we just said it before. So plus 1, plus 2, plus 3, plus 4. And then for 8, it's just minus 2, right? So we need to make the positive 1. We must turn it into a negative 1. So we have a negative 1, plus 2, plus 3, plus 4. And for 6, it will be 10 minus 4, so we just turn the positive 2 into a negative 2, so it's a plus 1 minus 2, and then plus 3 plus 4, and then for the 4, same thing, minus 6, so we just turn the positive 3 to a negative 3. Then for 2, you know the drill, plus 3 minus 4. Then for 0, we just, since it's minus 10, we just either turn 1 and 4, or 2 and 3 into negative. So I would take 1 and 4. So negative 1 plus 2 plus 3 minus 4. And then let's go down again. So now we look from the negative 10 perspective. So negative 10 is just negative 1 minus 2 minus 3 minus 4. Now, if you want to make it a minus 8, we just turn the negative 1 into plus 1. So minus 1 minus plus 1 minus 2 minus 3 minus 4. And then negative 6 is just turning the negative 2 into positive 2. Then negative 4, we just perform action on the 3. Then for negative 2, it would be negative 1, negative 2, negative 3. Plus 4. Okay, so all of these are doable. As you can see, all of these are even numbers. So all even numbers between negative 10 and 10 included. So how many of them? Let's just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of them, and 11 would be the answer to this question, which is problem 4. So hope you guys understood. Now for the last question, so which is here. This is also just a problem of listing out. So how many 3-digit numbers have sum of digits equal to 4? Now our digits could be ranged from anywhere from 0 to 9, but note that our hundreds digit, so we have a hundreds digit, a tens, and then a ones, right? So this one could range anywhere from 1 to 9. It cannot be a 0, because if it's a 0, then it's a 2-digit number. And this one could be 0 to 9. This one could also be 0 to 9. So let's start case by case. So since the sum of digits is equal to 4, let's cap a maximum. So the maximum is when the hundreds digit is 4, then the other two can only be 0. Then the minimum is 1, and then the back ones will be 3. So 103. 112, 121, 130. Very easy. And then if our hundreds digit is 2, then 202, 211, 220. And then we will have, let's see, 3. So 301 and then 310. Just count how many of them there are. So after we perform a bit of counting, we find that there are actually just 10 of them. And then indeed 10 is the answer. So these problems in the front are, I would say, honestly, quite effortless. You don't need a lot of brain power to do these because there are more difficult ones at the back. So I hope you guys can answer these questions in the front accurately, correctly, quickly, so that we have more time to discuss the problems at the back. Okay? Now, this is the video for today, and then for the next video, we'll be discussing problems 6 to 9. For juniors, and then 1 to 4 for seniors, because again, there's an overlap. So that's all for today. Bye bye.